Hello, hello, hello. Welcome to another wonderful week of e-learning. This is our last review for the year. There's Unit 11 that will not be on the AP exam this year, so I will not be going over it. Don't want to give you guys something to do you don't need to do. 9 and 10 are bunched together here because 9 really is a lead-in to Unit 10, but the reality is Unit 10 is what we need to worry about. So I'll be relatively quick with this. A sequence is just a set of numbers and they just keep going. But a series is, as I like to say, when it gets serious, because those problems become very hard. Take that sequence and now you're adding them up. And my pen seems to be malfunctioning here, so I apologize for the sloppy nature of my handwriting. Adding them up and seeing if they add up. This one does not. It diverges, is pretty much what all of Unit 10 is about. However, you do need to know the limits of a sequence when you do something like the ratio test. And they say, if n goes to infinity, what happens to n over n plus 1? Well, that goes to 1. Okay, that's fine, that sort of thing. So, L'Hopital's rule, make sure you check. If I plug in a number and I get 0 over 0, or infinity over infinity, okay, take the derivative of the top, take the derivative of the bottom, not the quotient rule, and off you go. That one's up to you. You've done that. Relative rates of growth, which one goes from slowest to quickest? Well, we know that natural log is slowest, and then we get anything, that's wrong. I was going to say any exponential, but no, not yet. Any x squared, x to the third, to any exponential, the classic being e to the x, up to x to the x, and then factorial is the fastest growing one of all, which we use to analyze whether a series converges or diverges at a first glance, but not to actually prove it. Improper integrals, we had things like what is the integral from 1 to infinity of 1 over x squared. And we learned to say, well, we'll just write it as a limit problem. So we can write it as a regular old integral and do all the problem, and then when we're done, plug in infinity. And if it works, great, then we have a converging value. If it doesn't, then it diverges. So geometric series and sum of a geometric series. You'll see this in your problems for today. They're classic. If it's geometric and r value is between -1 and 1, it'll add up. So things like 1, -1/2, 1/4, -1/8. You would say a naught equals 1, r value equals -1/2, so it's 1, that value, over 1, just some random one, minus -1/2. And we do this fun stuff, 2 over 2, and we get 1 over 3/2, which is 2/3. So that would add up to 2/3. Seems a little bit wrong. 2 plus 1, 3/2. Nope, 2/3. Now, general form for a Taylor series is the one that keeps popping up. You don't need these this year. Interval of convergence, do the ratio test. If they ask for the radius or the interval of convergence, do ratio test. I may have a problem on that right now, but if not, you'll see one soon. A Maclaurin series would look like f of 0 plus the derivative at 0 times x plus the second derivative of 0 times x squared over 2 factorial plus the third derivative of x at 0 times x to the third over 3 factorial. And a Taylor series more general form would be f of a plus f prime of a x minus a plus f double prime of a x minus a squared over 2 factorial dot dot dot. And yes, you will see those on some of the problems I give you. Will you see them on the test? I don't know. I have an opinion that the 15-minute question is just going to be a infinite series question, just like question number 6 is on all the FRQs. But that's just a total guess out of thin air. So here's your ratio test. What are all the values which the series converges? And there's some complicated algebra coming up. So ratio test, we say, well, the limit as n goes to infinity of n plus 1, 3 to the n plus 1, over x to the n plus 1. And then we divide by, but we don't do that anymore. We immediately flip and say the original series. So then the x goes on top, the n goes on bottom, and 3 to the n go on the bottom. And now we break this down into, well, what's the limit as n goes to infinity of n plus 1 over n? And that's a sequence question. So we get closer and closer to infinity. This gets closer and closer to 1. 3 to the n is going to cancel with that. X to the n is going to cancel with that. And we're left with 3 over x. So we would say, well, then 3 over x has to be less than 1. That's what the ratio test says. Hey, this converges if it's less than 1. Well, when we have an x in it, we say, oh, then there's variables here. We don't know. Now watch this. This took me a little while to sort myself. Absolute value we have to break into 2. We don't usually because it's pretty easy. The first one we assume x is positive. And then we just multiply both sides by x. 3 is less than x. We write it the other way. X is greater than 3. Or we assume it's negative, in which case we flip the sign. Why? Because we're assuming it's negative in there. That doesn't make any sense. No, it doesn't. We multiply by x. What do we say x was? It's negative. When we multiply by a negative, we have to flip the sign. I had a little trouble with that. Divide by negative, we got to flip the sign again. X is less than negative 3. In other words, these are my answers. And that is the absolute value of x is greater than 3. You're probably saying, hey, there's a quicker way to get there from there. I usually have to break everything down because I'm just not smart enough to look at it and do it that easily. So here is your last example problem. I only put 2 in here because they cover the gist of what you're looking at. Whatever. So we need f of 0. Well, that's natural log of 1 minus x at x equals 0, which is the natural log of 1, which is 0. So first term is 0. Now we need f prime of 0. Well, that's 1 over 1 minus x times negative 1, which I forgot the first time I did this, at x equals 0, which is negative 1. So we get plus negative 1 times x. It's at 0, so it's just going to be at x. If it was at 1, it would be x minus 1 in parentheses, but it is not. All right. Now, I have to rewrite this as negative 1 minus x to the negative first, because otherwise I'll screw up the derivative. F double prime at 0 is negative 1 minus x to the negative second, chain rule negative 1, x equals 0. So positive, negative 1 over 1, negative 1, minus, plus, negative 1, x squared over 2 factorial, which is just 2. 1 to go. We had this, f double prime of x is negative 1 minus x second. So now I have to do the third derivative. Out of space a little bit here. f1, 2, 3 of x is negative 2, 1 minus x to the negative third times negative 1 chain rule. So it's negative 2, we plug in 0. This cancels out and just becomes 1. We get negative 2 plus negative 2 times x to the third over 3 times 2 times 1, but who cares? And we end up with just negative x to the third over third. So here it is. Some of you might notice there's an easier way to do that if you have all those properties memorized, but I wanted to show you how to do it the long way because that's the way I can always count on. That's a lot of math. You got a lot of practice to get good at infinite series. We will do 15, 16, 17, 18, 19, 5 more free response questions on them because you just can't get enough practice. And as I said, I expect the second question to be almost entirely infinite series. They're probably going to be smart and sneak in another concept or two in there. maybe a linearization, something like that, but it'll mostly be an infinite series problem. That's it. Good luck.